and to hell with all of us.
Sonny?
We're okay. We're all okay.
Santa Maria, Madre Dios.
Lieutenant Jones.
Who is he?
He's a Miami Dolphin fan.
Homicide, Lieutenant.
There's all kinds. I can smell them, but I can't understand them.
What is there to understand?
Reason, motivation.
Bottom line is M-O-N-E-Y.
It's a losing proposition.
Usually is.
One you can't refuse. It's the politics of contraband. It's smuggler's blues. Smuggler's blues.
TV. Went to the electronics store and bought a couple of capacitors. And meanwhile, I found here, let's see if I can show it to you. I need a pointer. This potentiometer was broken. This little tab right here was broken. And this is not an ordinary potentiometer, this is actually a board with 4 integrated potentiometers. This one right here is the vertical height. That was the reason the height was screwed. And I could just put in a different, drill the board and put in another pot or solder it to these little rivets. But the problem was that my local electronics store didn't have set 750k linear pot. They didn't even have a 1 meg. They only had 470k, which is the most used value on modern electronics. So I came empty-handed, and as you can see here on the floor, I disassembled a couple of old potentiometers. This was a 22k and this was a 3 megs, and I salvaged the wiper and other parts. I actually managed to put in here a different wiper from another potentiometer. I put in a screw and a nut in the back. I epoxied the nut to the screw and the screw to the wiper itself so it doesn't rotate independently. And although it's not a very appropriate repair, it will work. It's not something you need to adjust every day. It's not even accessible, only accessible if you remove the cover of the TV. So after replacing a part, after repairing something, you should always test. So I'm going to test the TV right now, and you should test because we make mistakes. It's natural. We put electrolytics backwards. We replace film capacitors with other capacitors that are 10 times the value. We do all sorts of mistakes, and if we test each step of the way we perform a test, we can determine if it's a new malfunction that developed or if it was a mistake in our repair. So the pot is making contact. I'm going to test the TV. After I test the TV, we will replace some caps, some critical capacitors. I got the correct fuse here. I bought a box of fuses. Let's see what else did I get. Okay, so we have the TV working. It's producing a nice picture. The mirror is incredibly scratched and dirty, but Let me see if I can film it from the front. Still have a lack of height, but that's because of the potentiometer not being adjusted properly. Let me try and fix that. Some tool that won't shock me. I got here a pencil. Let's see if I don't die right here. Okay, there we go, full height. There's some marking happening between the vertical output transformer and that capacitor. I don't know why. Look at this. I was inspecting around the vertical output transformer for the reason for the arcing. The arcing seems to be happening right here between the sheets of the transformer core. And look what I found there. There's some sort of transistor laying around and it's loose in there. It looks like somebody lost that and it got caught between the legs of the transformer. I wonder if that is what's causing the arcing. I'm trying to remove it. There you go. It's got 4 legs. AF201. I wonder how that thing got caught in there, but I bet that it was the problem that was causing this thing to arc. Because if you look down under here, there's a big gap between the windings and the actual metal core of the transformer on the top, on the place where it's arcing. And for the sides they have this thick plastic thing. This would withstand a massive voltage before it would arc. So I think the transistor was touching that leg of the transformer and touching this metal right here, and that was what was causing the arcing on the top. But I'm going to fire it up and see if I was right. It's warming up. We have a picture. Looks like that cured the problem. It was this thing that was causing the arcing. And I'm very smart, so I'm going to put it on top of the TV so it will fall. Well, I was actually a little bit dumb and I bought 22 nanofarad 1000 volt capacitor. It's not this one, these ones. 22 nanofarad MKP 1400 volts. And the idea was to replace that big guy, that brown big guy right there, but that's actually 220 nanofarad. I'm not going back to the electronics store again. That guy is fine, it will be left in place. I'm going to replace only the red one. The red one is the boost filter. It charges and discharges at 15 kilohertz so it needs to be a very robust capacitor. Often when we replace vintage capacitors with modern replacements, we need to extend the leads of the component. So what I do is I have a bunch of scrap wire from electrical installations in houses, the type of wire that goes inside the walls, and it's a 1.5 millimeter wire. I also have 2.5, but that's overkill for this application. I cut a little bit of copper, I J-hook it, I crimp it with I crimp it to the capacitor lead with a pair of pliers, and then I solder it. It's not just blobbed, it's actually has a very solid mechanical connection before I solder it. So then I use the old component as a template to bend the leads, and then it's just a matter of soldering it into the actual PC board. Okay, so the two critical capacitors have been swapped out. I actually went here to my stash of new and used capacitors, and I found a good replacement. It's a Nero MKT 220 microfarad, and this is rated at 1000 volts. A bit overkill, but it will last for the whole remaining life of the TV. The other blue one is the boost reservoir, and it replaced this guy. Curious thing about this capacitor is that it has a frequency rating. See there, 21 kilohertz maximum frequency that this thing can operate, and these capacitors on the horizontal circuit always seem to have this K. I don't know if you can see. Let's see if I can focus. See that K over there? Another thing I want to show you. Be very, very, very careful if you decide to blow the dust off of a vintage TV or radio. Let me show you why. See there? Right in the center of the picture, you see there two picking coils with a bit of glue inside. Well, the glue was me that I put there the glue. Why? Because they were loose. The original glue dried out. These coils are only held to the board by glue. And you see there in the center of the image something that looks like a human hair or an animal hair. Well, that's the actual copper wire from the coil connecting right next to that transistor in the center. If you blow this thing with compressed air, it will rip that coil apart. Most of the times you can bridge it with a piece of wire and you will be fine, but you don't want to start messing around too much with these things. Just leave it as it is. If it's dirty, no problem, leave the dirt. It will not harm anything. I'd rather have a TV working but filled with dust than a TV super clean but not working and with a difficult to find fault or problem. Of course, if you want to go overkill and spend here a couple of 100 hours, you can clean it with a cotton swab, etc. Be careful when using alcohol or other liquid to clean the board, because some capacitors are porous, they absorb stuff. This TV that's here by my side, it was completely dirty with cigarette crust. It was completely sticky. You put your finger on the board and you would got your finger sticking to the board. So I actually cleaned that with isopropylic alcohol. But before the cleaning, the TV worked. After the cleaning, two capacitors shorted in the horizontal oscillator section. The horizontal oscillator did not start. The damper tube red plated and melted and caused a bunch of problems. The IF was not working correctly. I needed to let the TV warm up for a couple of hours, let it soak, and let that crap evaporate. And it was alcohol, so some capacitors don't like that. Don't use any type of cleaning liquid, only air, cotton swab. If you want to use alcohol, use it on the cotton swab. Do not pour it in the board. Do not wash it on the dishwasher like some idiots do. Just when you're cleaning, sometimes you are ruining stuff. Don't clean it too much. That's my advice. Well, isn't it ironic that we have these radial capacitors and they bend the lead in order to form an axial capacitor, and these days we can only buy this type of crap and we have to extend the leads to make a radial one? Isn't that a bit ironic? Sure that is. Nice thing about Philips TVs, and I know that this is a Blaupunkt, but this screams Philips to me. Component choice, circuit layout, the tuner, controls, type of controls, etc. It's got a lot of Philips influence on it. And one of the nice things is that the small electrolytics use this rubber thing right here. You can just stick a modern electrolytic in there. You have the correct lead length. You got here a bulge marking the negative side, so you don't make mistakes. And if you want a period correct look, you install the capacitor like I did right there. Then you cut this thing open, remove the innards, and just stick it on top of the new one, glue it, whatever, and you have yourself a restuffed electrolytic with very ease. I'm not gonna do that because I may end up trying to probe right here and it will give me no voltage reading, so I don't want to get confused. I don't mind that. It looks modern, but I don't mind it. My major concern when replacing components is I want the component in exactly the same place as the old one, if it's possible in a similar form factor. I don't like putting solder tags, components in places that they weren't originally, because that creates problems when troubleshooting in the future. For example, these two capacitors are not the original, they don't look like the original, but they are placed in the same place. This one originally was rated at 400 volts. I'm going to put here a mark saying that, because in the future I want to know. This one originally was 56 nanofarads and I put in a 68. I'm also going to write that down. Maybe I'll write a piece of paper and hang it on the side of the TV. And let's continue with this. Replacing components on these vintage circuit boards can be quite tricky. First thing, the traces are not very well glued to the board. You can easily lift the trace. And troubleshooting involves flipping the board around in one side or the other. I actually prefer point-to-point wiring. Most people get scared when they see that. They say, oh, that's a rat's nest, it's very difficult to troubleshoot. Well, no. It's actually much easier. You flip the chassis on the side where the wiring is, and you can do all the troubleshooting there. In this, you need to troubleshoot on the top to see where the component is, and then you need to guess where the solder pins are for that component if it's not marked on the inside. Sometimes we end up hitting the wrong pins trying to pull a component that's not being desoldered. Sometimes it's a big mess. So what do I usually do? When I have components that are horizontally mounted, I got a piece of wire like this. I wrap it around one leg of the component. In this case I'm going to pull this capacitor right here, and I do a little bit of a pulling force, push. I always get confused with the two words push and pull. I pull the component lid while I heat the soldering on the other side of the chassis or the board. And then I can lift off one leg of the component. Then I simply grab it with my hand or a pair of needle nose pliers and pull the rest off. When I'm working with radial components like this, there's always one big problem. The component is like this. You heat up one leg and you pull it halfway, and then if you don't heat the other leg very well, if it's not well melted, when you do that, it will lift off the trace. So I also don't like using solder sucker to suck the solder, because I don't like to heat this too much. If you heat it too much, if you leave the iron for too long, it will degrade the trace. The trace will unglue itself from the board. Excuse me for the awkward terminology that I'm using. It's a struggle for me to speak in English. What I usually do is, if the leads are long, I cut them as short as I can. Then when I pull one leg, I make sure that I pull it all the way, and then when pulling the second leg, I pull the component like this, not like that, like this. That way I never ever lift traces on these vintage boards, never. That's not a problem for me. So all of the small electrolytics have been replaced, with the exception of this large can. I was going to restuff this, but I just realized now that there is no way that I'm going to be able to fit these two inside. Those two would go in any corner or little space that would be left, but these two will not go in there. So restuffing this is not gonna happen on this TV. I will find a way to put them there. I don't like to glue anything, I don't like to tape it, I don't like to use hot glue, silicone, solder tags. I will try to minimize the use of those, and let's see if I can find an ingenious way to put these 4 capacitors in here, and we're good to go. It's working. I managed to cram 4 capacitors on the tight space available. I replaced the smoking resistor, or the smoky resistor, with a new one, and it's finished. So just another note here, in case you're wondering why did I replace these small electrolytics although the circuit was working fine. Here's the reason. This one is already starting to show signs of physical leakage. Matter of fact, it has quite some obvious signs of physical leakage right there. This one also, little bit right there. This is fine, looks fine. This looks fine. The rubber is deteriorated, but it still hasn't leaked yet. This is fine too. So out of 5 capacitors, 2 are visibly degraded, and since they are stuck in those yellow rubber things, we cannot see them, cannot see the electrolyte leaking. So it's always a good practice to replace that.